All right, well, good morning, everyone. I'm Tyler Soderstrom from ExxonMobil Technology Engineering. And today I want to talk to you about what I think is a really nice piece of work that's been put together around the HMI for the ExxonMobil's Open Process Automation Lighthouse project. So I'll talk about some of the insights that we've gotten from going through that whole process. So just want to give a little bit of nod here to some people who helped us out on this project. In addition to myself and others at ExxonMobil, a lot of the detailed work on the development of this HMI was done by one of our service providers, Wood, and Alex Eaton is very key to that work. And Alex is going to join us a little bit later here on up on the stage as a panelist as well. So what this is, really what the focus of this is all about is, in my opinion, how the open process automation standards have really enabled us to have and create a reusable, flexible HMI package that's not tied to any one specific vendor's tool set. I think this is a very important thing that's been enabled by our use of the open process automation standards. So I'm going to talk a little bit about specifically what were some of the drivers for the development of this. What are some of those key design decisions that were part of this, and kind of close up with what was the overall impact we see of being able to create this flexible design for an HMI. So I think there's been a lot of discussion at this meeting on the topic of open process automation. Hopefully this is something that isn't new to everybody. I don't want to spend a lot of time dwelling on the details, talking about the reference architecture, but the main point I want to get across here is that from the end user perspective, really the importance of open process automation is about providing that open, secure, interoperable system environment that enables us to, when we're thinking about building systems and future projects, how can we make decisions about the equipment that we use so that we're only picking the components that are right to solve the problem at hand, and how are we able to pick and choose the elements that are the best from each kind of vendor to pull it together and come up with the system that's the most fit for purpose for what we're trying to do, and not having us locked into a one specific vendor's set of tools and be limited by what those offerings are. So the next thing I want to touch on is just a little bit of background about where this all was coming from and where it was all applied. And that's ExxonMobil's Lighthouse project, which was really just recently completed. So the Lighthouse project, from the open process automation point of view, this is really the culmination of years and years of effort of trying to bring the ideas of open standards and bring them up to the point where they're practical to be used on a full-scale system. So the Lighthouse project was effectively a DCS replacement project for a small site in Baton Rouge. But even though it's a small site, it has all of the elements that you would expect in any manufacturing facility, even of a larger scale. It has its own utilities. It has its own distillation trains. It's a polymer processing facility, so there's some pastillation things on the back end. And I've got a couple of photos here to show that what are the things that happen at the site, and including a shot of what's the operator console down there at the bottom with the HMI that I'm talking about. So a big portion of what's happening here is open process automation has really become a reality in this case, and following these standards is one of the things that was really enabling us to create a reusable, functional HMI for us to be able to run this plant. So when we talk about the HMI, there's a lot of kind of high-level objectives that really need to be met. And one of the first things that we had to consider was we're coming into a facility that's been operating for a long time. It's in an area where there's lots of similar manufacturing in the same general area, and people have been exposed to the same kind of tools to operate the plants. So keeping that familiarity and the look and feel of the way that the operator interacts was one of the key objectives. And I think one of the most important ways that we're able to do that is by maintaining this visual and functional consistency across the displays and across everything that the operator has a span of control over. And in order to do that effectively, we really had to take a step back and think about how can we do this with a modular, flexible design, make use of reusable objects, leverage object inheritance, and things of that nature. So that was very much key in the design decisions. Another important element of any kind of modern HMI is that you need to be able to be integrated with other third-party applications. So if you have a very general HMI environment, you could program everything that you needed to do in that environment, but that's really time-consuming and difficult to support, especially when there's other third-party applications that are readily available to do certain tasks. And I'm talking about things like trending packages or alarm management, tying into recipe databases, all of these kinds of things. You want to be able to have that seamlessly integrated into your HMI. So this is an important consideration as well. Another real core important piece of an HMI is synchronization with the underlying control system. So if controls were changed, we really want to make sure that we're not setting ourselves up to do a lot of rework and having to do configuration in multiple places. So knowing that information flows from when changes are made to the controls to the HMI without having to do a lot of extra engineering was paramount. But I think really the most important piece that I'm going to keep coming back to is that this whole thing is built on open standards, and the open process automation standards define a OPC UA information model. And as long as you're designing your HMI to be built on that foundational information model, this is the piece that's going to enable you to reuse this HMI on systems regardless of what the hardware is. As long as it's consistent with those standards, you should be able to use it as a drop-in. So I'm not going to talk about every one of those items in detail. I'm going to talk about a few in more detail than others. And perhaps some of the other ones can be questions for the panel discussion. But on the subject of visual and functional consistency, I think that kind of the best way to illustrate the importance of this and where this is used is in the presentation of alarms to an operator. So on the left-hand side, you'll see there's a little alarm object, and that would appear if when alarm becomes active. And depending on what the severity of the alarm is, the look and shape and behavior of that would be different. But that's an independent object that's now utilized in all of the higher level objects in the displays. So whether that's being put on a controller shape, whether it's on a valve shape, whether it's analog, whether it's digital, that same object is embedded in all of the other objects all the way. And this philosophy of making use of embedded objects and using the same objects gives you this consistency. But not only that, if there is any changes that need to be made, you make it down in the lowest level object, and that change then propagates to all of the instances and uses of it with anywhere on the HMIs without having to go through and update individual displays. I went back to familiarity. I think again this was a big one for us, and sticking with the philosophy of trying to leverage all of the available standards. When we looked at the design of the HMI in general, we wanted to make sure that it could have that consistent look and feel, and we wanted to leverage the HMI standards that are out there. So this should look familiar to anyone who's looked at the ISA 101 HMI standard. Now, with with that said, it wasn't like we built in something and made it perfectly static either. If there's a need to change the sizing of objects or the color scheme of objects, this is something that, like everything else in this, was designed very modular and very flexibly. So you could go down into the lowest level and make those changes, and of course they would propagate all the way through the system in the HMIs without needing to touch any displays if you wanted to change that configuration. Another piece that's very important to a modern HMI is the integration of information across the displays and across the system itself. And again, I think alarms are always a really good example of how to demonstrate some of the needs of this. So if you think about where an alarm occurs, the alarm has a lot of information associated with it. Is it a high alarm, a low alarm, deviation alarm? What's the priority of that? That information has to come up and be displayed in the individual shapes that are on the displays. And those shapes and that information has to be consistent across displays. So if you look at one display versus another that happens to have some overlap on it, you want to make sure that you're seeing the same information presented the same way. If there's more than one alarm that's active on a point, you need to make sure that only the highest level alarm is displayed, because you can only display one thing at a time, and make sure that's consistent as well. And as you go up even further, if you're looking at faceplates to operate those, you need to see that same alarm information in that displayed concisely. And finally, at the top, the operator always has a master alarm summary, which displays all of the active alarms on the unit at that time. And all of these things need to be consistent and show the same information. And in the case of these open systems, this becomes a little bit more of a challenge, because not everything is all located in the same place. So in the case of alarms, for example, the alarm engine lives on each individual controller. The master alarm summary is its own application by a separate third party. And of course, the HMI itself runs off of another server. So managing the integration of all these devices consistently within the HMI is a very strong challenge. Going back to the theme of integration and third-party products, we said before, we don't want to reinvent the wheel on things. We don't want to build stuff into the HMI itself that you could accomplish the same task by bringing in a third-party product. So when it comes to third-party products, which ones we use, we also want to stay with this theme of flexibility. And rather than picking one that we say we're always going to use, we want to have the HMI capable of dealing with different products, and we do that by specifying what the interface to those products would be. And that way, if at a time later we choose that we want to swap out one product for another, all we have to do is change the definition of how to access it through that interface. So once you've got those different options configured, it's really as simple as going through and selecting a different checkbox for which option you want to use for this particular implementation. And we're looking at that for a lot of the places where third-party applications would be done. Like I said, trending and alarm management are probably some of the two that people are most familiar with. Another section that is very important. This is a rather complex topic, so I don't want to get too deep into it right now, and maybe it's a subject for questions during the panel. But the idea of the need to have the HMI synchronized with the things that are in the underlying control system is very important. If you don't have this automatic synchronization, it's very difficult to keep things up to date. If anytime somebody changes a range on an instrument and you have to change it in the control system and you have to change it in the HMI, it's just a matter of time before these things get out of sync. So this idea that we avoid rework and that we have this built into the process was another part that was really paramount to the overall design. Again, like I said, I'm going to come back to this several times, but I think that really one of the key elements as to why this was successful was we were working with the OPAS information model. And that this has really been what's enabled us to come up with something that we know will be reusable if we look at applying this to systems that was built with other vendors' equipment, other than what we happen to use for this instance in the Lighthouse project. Again, thinking about flexibility in the design, we also acknowledge that the standards aren't perfect and the standards aren't set in stone and finalized either. So part of this design is to include this modularity, so that if there are any changes that happen in future versions of the standards, we know that we can go into the objects that use that rely on that, where things are situated in the information model, make those changes, and again, that information will be propagated up through all the objects, and we won't have to rework anything on the individual displays themselves. Ongoing development, future challenges. This is another area where I think I could probably talk for way too long on, so maybe I'll also defer this to the details to the panel discussion. But I think that the short answer here is that we did our best to stay in connection with all of the standards as they were available. But as we know, standards are never perfect. There's always a little bit of white space in there, and you have to make some assumptions and deal with some things that around the edges that really enable the whole thing to function well. So in the future, we'd like to look at things that tighten up some of the standards, that utilize some other pieces that may be part of the OPC-UA standard in a more detailed way, and use that to eliminate some of this middleware, so that the maintenance and support of these HMIs built off of this toolkit in the future will become more simple as well. So what I want to kind of end with is talking about where we see this and what the impact of this is for HMI. Again, when we step back and we look at the overall design, at first you might say, oh, you made an HMI for a plant. Anybody can program that, but the idea wasn't just to make an HMI for this plant. It was to make an HMI that enables us to be using it for future projects and subsequent projects, and do it with little additional effort from the initial outlay. So building things up in this flexible modular way is really going to enable time savings, and time savings directly translate to cost savings. And again, we've designed this so that we're not locked into a particular vendor when it comes to the control systems and the underlying pieces. We know that since we're looking at things that are consistent with the open process automation standards, that in any subsequent project, we're just going to be able to use this HMI, to apply this HMI, and get things up and running as quickly as if it was on a single vendor system using all of their kit. And we know that we don't need to be held to just to one particular vendor's offerings. So in closing, I think I just want to reiterate a few of these main points. I think that the Lighthouse project has really demonstrated that these principles of open process automation are real. And this HMI is a really good example of how we've utilized the standards to come up with something that's really flexible, reusable, and keeps us from reinventing the wheel on future projects. So this is something that I think that the folks at ExxonMobil and other companies have a lot of interest in and a lot of excitement behind. So I encourage you to reach out to any of us if you have any questions, whether it's about OPAS, whether it's about this particular HMI work or the Lighthouse project. We're always happy to speak about these things. So with that, I'll close, and thank you.